To solve this question, determine the length of backwater curve caused by an efflux of 1.5 meter in a rectangular channel with a depth of flow of 2 meters and width 50 meters. So first we should know what the question is asking. So this is a backwater curve. Okay, backwater curve means it's going to be like this. This the slope is usually down facing, but dy by dx is going to be more than 0. This is backwater curve. So here there is an efflux of 1.5 meter. That means there is some kind of obstruction here, and this particular height is efflux is 1.5 meter, and the rate of flow is 2 meters. So the normal depth of flow is 2 meters and efflux causes 1.5 meter. So I'll draw the diagram again so that it's uniform. Like this, it's like this. Okay, so 2 meter is this height. So what height is this? This is going to be 3.5 meter. Where this is 2 meter, then this is going to be 3.5 meter. So our first we should know the formula. Delta this is equal to mod ei plus 1 minus mod ei upon s naught minus sf bar. So for that we have to calculate ei corresponding to y is equal to 2 meters, which will be equal to 2 plus v square by 2g. So we don't know v here. For v we have to calculate it, but let's calculate the discharge directly. Discharge is equal to 1 upon n a r is to power 2 by 3 under root s. So since this is 2 meters of depth, so usually the flow is at normal depth if it's a constant depth. So we will assume that this is a normal depth, and the bed slope which is given as the frictional slope. So this is sf. So we'll substitute the value of n 0.03 into area 2 meter into 50 meter width into wetted area upon wetted perimeter raised to power 2 by 3 under root 1 upon 2000 is equal to. So I'll use my calculator here. So the discharge comes around 112.4 meter cube per second. So E1 will be 2 plus 112.4 upon 2 into 50 square upon 2 into g, which will be equal to 2.0644 meter. Now I'll calculate ei plus 1, which will be equal to 2 plus 1.5 plus 112.4 upon 3.5 square upon 2 into 9.81, which will be equal to 'll have to calculate it again. This is not 3.5, it's 3.5 into 50, since the width is 50 meters. Yeah, so n square (3.521 meter). Now we know these two values. Now we'll have to calculate in these two values. Okay, Let's calculate these two values. Since S naught is given, S naught is equal to 1 upon 2000, we have to calculate SF only. So for SF we have a formula that Q is equal to 1 upon N A R raised to power 2 by 3 under root SF I. Say it I, and discharge is going to be same. So the discharge was 1 put into 4 into 0 point, what was the value of N? 0.3 into area is 2 into 50 into 100 upon 54 raised to power 2 by 3 under root SFI. It implies that SFI. So this SFI is going to be equal to S naught, because we assume that the depth is at a normal depth of flow. It's going to come around 2000 only. And for I plus 1, now 0.03 into 3.5 into 50 into 3.5 upon 57 raised to power 2 by 3 under root SFI plus 1. Okay, so it implies that SFI plus 1 is going to come around, let's calculate, 50 into 3.5 divided by 57 raised to power 2 by 3 into 3.5 into 50 divided by 0.03 minus 1 into 112.4 whole square. So it's coming around 8.32 into 10 raised to power minus 5. So now I'll be substituting the values. The formula was this. So SF bar is going to come around 1 upon 2000 plus 8.32 into 10 raised to power minus 5 divided by 2. It's going to come around 2.916 into 10 raised to power minus 4. So EI is 2.06 3.521 minus 2.0644 upon S naught is 1 upon 2000 minus 2.916 into 10 raised to power minus 4 modulus. It's going to come around. Let's see what result come around. So it's coming around 6989.52 meters. So it's close to 6.99 kilometers. This is going to be our answer. Hence solved. Answer is correct.